Hello everyone, welcome to Rector Plus. And I am excited to welcome you on this masterclass on computational thinking and its importance in the modern world. You know, computational thinking is a powerful problem solving approach that can open doors to countless opportunities in today's technology driven landscape. So, now let's go into the concept. What is computational thinking? Computational thinking is a method of breaking down complex problems into more manageable parts and solving them systematically. Actually, most of the people think that computational thinking is all about for computer science and coding, but not just about coding. It's a way of thinking that can be applied to any discipline. If you observe the following image clearly, you can find exactly what is computational thinking. So here at first you have the problem, then it break down it into smaller tasks. Here at second step you have to identify the similarities, differences and patterns within the same problem. And then at third step you need to gather all the general principles and formulas and filter out unnecessary information. Finally, at fourth step you need to identify and organize the all the steps needed to solve that particular problem. So now let's go into deeply what exactly is computational thinking. Yeah, computational thinking is a method of breaking down complex problems into more manageable parts. Actually, the computational thinking is combined of four key concepts. That what they are I have said to you in these examples. This each one of four steps are named separately. First one is decomposition. Second one is pattern recognition. Third one is abstraction. And fourth one is algorithm design. Listen clearly. It is very important to understand each one of these four key concepts. So, now what is decomposition? It is a method of breaking down a problem into smaller tasks. Then it is more manageable and understandable. Let's clarify you it with an example clearly. What is decomposition? So let's assume that you are planning to celebrate your friend birthday party. Then what you do, you have to break down all the planning to tasks like choosing a venue, sending invitations, ordering a cake and more. Then it is very easy to you manage the all the party very simply and easily. That's what decomposition is. Second one is pattern recognition. Identifying similarities and patterns in problems is called pattern recognition. So now let me explain it with an simple example clearly. Let's say when you're learning multiplication tables in your childhood, that you are recognizing that multiplying by 2 anything is like just doubling that particular number in tables. This is what recognizing the patterns in the problems itself. Third one is abstraction. Generally, abstraction is filtering the unnecessities. Actually, here also same that focusing on the important information and ignoring the irrelevant details. So now let me explain it with an example to understand what it is exactly. Let's think that you are designing the website for your final year project. While designing, you only focus on the layout, UX and content rather than the underlying code. Fourth one is algorithm design. In algorithm design, we identify and create a step by step solution to solve a problem. Let me explain it with a simple example for clear understanding. While solving a math problem, you have to be follow a series of steps like understanding the problem, identifying the variables, and applying the appropriate formulas. Finally, calculating the solution. So here, while solving a problem, you have maintained a series of steps which is an algorithm. So this is what algorithm design. Yeah, these are the four key concepts of computational thinking. Importance of computational thinking for young people and how it is necessary to develop as a skill for them. In today's competitive world, computational thinking equips young people with essential skills to thrive in various fields from science and engineering to art and business. It fosters creativity, critical thinking, and problem solving abilities. especially young people and students, has to be develop computational thinking since from their childhood. Educational institutions also needs to include the computational thinking as a subject in their curriculum by guidelines under by government. The one who has a thinking nature about any problem and then solve it, he can do anything about any social and economic problems. This is what social growth of a single individual. So now let's look out at the real world examples and applications where it plays a crucial role while we solving the social problems in our personal lives that are education, technology and everyday life. In education, it enhances learning in subjects like maths, science and literature. In technology, it is crucial for careers in software development, data analysis, and artificial intelligence. In everyday life, it helps in making informed decisions, managing time effectively, and even planning vacations. So, now let's put computational thinking into a practice with a fun activity. The activity is, let's think that you are a project manager for a simple project that is like organizing a school event. Now you have to be break it down that project using decomposition and identify patterns in it. Focus on key details with abstraction and create a step by step plan that is algorithm. Yeah, let's to wrap up. Computational thinking is a valuable skill that can empower young people to navigate the complexities of the modern world. Encourage the young students to embrace computational thinking in their daily lives and watch them excel in their careers. And that's what all about computational thinking. Thank you all of you for joining this masterclass on computational thinking and I hope you found it informative and inspiring. Remember, computational thinking is not just for computer scientists, it is for everyone.